They're some of the most powerful and, let's be honest, awe-inspiring forces on our entire planet. I mean, they shape landscapes, they create brand new land, and they hold a kind of raw power that has fascinated people for, well, forever. Today, we're going to take a journey right to the fiery heart of Earth's most dramatic architects, volcanoes.
You know, for centuries, we've looked up at these incredible peaks and seen one thing: mountains of fire. It makes sense, right? We even named them after Vulcan, the Roman god of fire. That name just perfectly captures the power, the awe, and even the fear they command.
But what if I told you that our most basic idea about them is, well, wrong? What if the thing we call a volcano isn't actually a mountain? Okay, stick with me here. Let's dig into this and completely reshape how we think about these things from the ground up.
So, if it's not a mountain, what on earth is it? Well, the real definition is the key to unlocking everything else. And this, right here, is where it gets really, really interesting.
Here's the most important thing to get. A volcano is, at its core, an opening. It's a vent, a crack in the Earth's crust where super hot stuff from deep inside our planet bursts out onto the surface. So, that giant mountain we see, that's just the pile of lava and ash that builds up around the vent over thousands of years. The mountain is the result of the volcano, not the volcano itself.
To really get this, we've got to take a trip. We're going to journey down, right through a volcano, to see what's really going on under our feet.
All right, let's go. We'll start at the top with the part we all recognize, the cone. That classic mountain shape built up from layer after layer of cooled lava and ash.
From there, we pass through the crater and into the vent. Now remember, this is the actual volcano, the opening at the very top.
And we keep going down the main pipe. This is like the plumbing, a channel that connects the surface directly to that intense heat source way down deep in the earth.
And we finally arrive at the heart of the whole operation, the magma chamber. This is a massive underground cavern just full of molten rock and gas, all held under unbelievable pressure. This is the engine room.
Seeing that magma chamber really brings that pressure cooker idea to life, doesn't it? So what actually happens down there to finally force an eruption? What lights the fuse?
Well, it pretty much boils down to a four-step process. First, the deeper you go, the hotter it gets. That crazy heat, plus a sudden drop in pressure from the rock above, allows solid rock to actually melt and become magma. Then you get groundwater seeping down, which gets superheated and turns into massive amounts of steam, adding even more pressure. And finally, all those expanding gases basically act like a piston, forcing the lighter magma up through the pipe and boom, out the vent.
Okay, so now we know how they work, but how do scientists talk about them? I mean, not all volcanoes behave in the same way. Their activity level usually falls into one of three main categories.
First, you've got your active volcanoes. Think Mount Etna. These are the ones that erupt pretty frequently, and there are over 500 of them around the globe. Then you have dormant or sleeping volcanoes. They've erupted before, but they're quiet for now, like the famous Mount Vesuvius. And last, you have so-called extinct volcanoes, which haven't blown their top in thousands of years. But here's the real takeaway. Look at that little note. Scientists are really careful about ever calling a volcano totally dead, because you just never know for sure what's brewing miles beneath the surface.
This brings up an even bigger question. Where do these vents tend to pop up? Is their location totally random, or is there a pattern to all this madness?
Oh, there's definitely a pattern. Think of the Earth's crust like a paved road. Volcanoes don't just punch through anywhere. They emerge at the weak spots, the cracks. And for our planet, those cracks are the boundaries where the massive tectonic plates all meet up. And wow, the data here is just incredibly clear. A staggering 80% of volcanoes are found where plates are pushing together. Another 15% are where plates are pulling apart. The connection is just undeniable. It's all about the plate boundaries. This intense concentration of volcanic hotspots, mostly circling the Pacific Ocean, creates the most famous volcanic zone on the planet, the Ring of Fire. It's this huge horseshoe-shaped belt of pure geological power.
And just to give you an idea of the scale, let's take a quick tour. The Ring of Fire runs up the Andes in South America, goes through the North American Rockies all the way to Alaska, and then curves down through Japan, the Philippines, and right into Indonesia.
It's a truly global highway of fire. All of this power has a huge impact on our world. But volcanoes aren't just one thing. They're not simply good or evil. They are both builders and destroyers. A perfect picture of how nature can be two things at once.
On one hand, the destructive power is just immense. Hot lava can bury cities, massive mud flows can wipe out entire farms, and the earthquakes they cause can trigger devastating tsunamis. But on the other hand, all that chaos is also incredibly constructive. Volcanic ash creates some of the most fertile soil on Earth. The heat and pressure form precious stones and minerals. They give us geysers and hot springs for tourism, and they carve out stunningly beautiful crater lakes.
And when they build on a scale that is just hard to wrap your head around. Cotopaxi, right there in the Ring of Fire, is the world's highest active volcanic mountain. It stands at nearly 6,000 meters tall. That's a massive monument to the creative power of these forces over millions of years.
So in the end, volcanoes are a fundamental part of our planet's life cycle. They create and destroy all in the same breath. They've shaped our past, and they will absolutely shape our future. Which leaves us with one pretty big question, doesn't it? Are we prepared for what they'll do next?